Okay, so in this video we're going to be looking at time zones. So time zones around the world are connected to the longitude. So depending on the longitude of a country or a location, that defines the time zone in which it sits. Now obviously there are some political influences and geographic border influences on time zones as well, but we want to focus sort of on the geometry of the Earth and how these time zones therefore come about. So as I said, time zones are largely determined by the meridians of longitude. And so because the Earth turns one full rotation, so that is 360 degrees in approximately 24 hours, now it's not exactly 24 hours, and that's why we have things like leap years and all sorts of things to make those adjustments. But it turns 360 degrees in approximately 24 hours. And so if we take 360 and divide that by 24, that means that the Earth turns roughly 15 degrees in an hour. And so that means that for every 15 degrees of longitude, the time difference is 1 hour. Okay, so time is measured relative to the prime meridian. We've talked about the prime meridian before now. That's how we measure. It's the sort of y-axis, if you like, of the Earth. It's where we measure all the other longitudes relative to. And so time is also measured relative to this prime meridian, and as we've talked about before, the prime meridian passes through Greenwich in England, and it's for this reason that time along the prime meridian is often referred to as Greenwich Mean Time, or GMT. More recently, however, there's a push to sort of universalise this rather than make it so England-centric, and time along the prime meridian is more recently being referred to as UTC, which is Coordinated Universal Time. And I know that should be CUT, but I think it's to do with, actually, it comes from French, the French interpretation of that. Okay, so locations to the east of the prime meridian. So if we're at the prime meridian and we go east around this way, so that would be, thinking about the prime meridian being in London, England, so that would be about moving across Europe and heading around in that direction, in easterly direction. 1 hour is added for every 15 degrees of longitude. Okay, so if you are east of the prime meridian, you are ahead of the prime meridian. So in Australia here, we are quite a long way east of the prime meridian, and so we are actually quite a long way ahead of GMT or UTC. Locations to the west of the prime meridian, so as we head around this way around the Earth, 1 hour is subtracted for every 15 degree of longitude, so they are behind GMT or UTC. So as I said, in Australia we are quite a long way ahead. Melbourne is located at a longitude of 145 degrees east, so that means we travel around the Earth a total of 145 degrees in an easterly direction. And so to work out how many time zones that is, we want to know how many lots of 15 go into 145. So if we do 145 divided by 15, it's about 9.67, so we'll round that to the nearest whole number, so it's about 10. So we are approximately 10 lots of 15 degrees to the east of the prime meridian, and so therefore we are approximately 10 hours ahead of GMT or UTC. We would describe this time zone as GMT plus 10 or UTC plus 10. So if the time in Greenwich is 10 AM, what is the time in Melbourne? So Melbourne is 10 hours ahead of Greenwich Mean Time, so 10 hours ahead of 10 AM. Now if you're comfortable with 24-hour time, that's a helpful thing here, because you can just add the 10 on to 10 and you get 20, and if you can make that connection that 2000 hours is 8 PM, then that's going to be easy. Or you might just work your way to midday and then go from there. So 10 AM, we're going to need 2 hours to get to midday, and then we're 10 hours ahead, so another 8 hours, so it'll be 8 hours after midday, so 8 PM would be the time in Melbourne. I find with the time zone work, a lot of getting out your fingers and literally counting is useful and helpful, and I would encourage it. Please don't feel embarrassed to do that. Literally thinking, right, 10 AM, okay, there'd be 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, and count it out on your fingers. Okay, so New York City is located at a longitude of 47 degrees west, and so we want to know how many lots of 15 degrees is that. So 74 degrees west. We want to know how many lots of 15 degrees is that. So 74 divided by 15 is about 4.93, so approximately 5 lots of 15. and so that means that New York is approximately, well, the time zones aren't approximate, we round to the nearest whole number and then that's the time zone. So New York City is 5 hours behind GMT or UTC. We would describe that time zone as GMT -5 or UTC -5. If the time in Greenwich is 10 a.m, what is the time in New York City? So New York City is 5 hours behind Greenwich, so if we take 5 hours away from 10 a.m, we get to 5 a.m. Okay, I'll write this in the same notation, but it's fine. Okay, so the diagram below shows the Earth pictured from above. So this is the North Pole. We're looking down on the globe. And we've got the meridians of longitude shown at 15-degree intervals. Okay, so each of these is 15 degrees, 15, 15, 15, 15, etc. Okay, and so that means that they each represent time zones. Okay, so any country falling within this time zone would be the sort of within the kind of +1 hour ahead within this time zone, 2 hours ahead within this time zone, 3 hours ahead, etc. And the other way behind. So what we also see here is what happens opposite the prime meridian. So if we adding on an hour for every 15 degrees as we go this way, and we're taking away an hour for every 15 degrees as we go this way, we get this problem happening over here, okay? And this is at the anti-meridian, which we've talked about before now, which is the meridian of 180 degrees longitude, and that's the approximate location of the international date line. So the international date line sort of runs through the Pacific Ocean, and it isn't perfectly straight because it bends around different countries so that you don't have the international date line actually falling through a country. But we have this idea of the international date line. Now if we travel across this line, and I'm going to clarify something here because the wording here is not quite right. I'm going to clarify what I mean and be clear about that. So if we travel across the international date line from east to west, so when we were talking about heading east and heading west this way. So we would call this the eastern hemisphere of the world and the western hemisphere of the world. So when I say here traveling from east to west, I actually mean traveling from the eastern hemisphere, which is over here, to the western hemisphere. So I mean going this way. But actually in practice, that is traveling in an easterly direction. So it's actually going from west to east. So apologies about that. Just be cautious. That should really say if we travel across this line from the eastern hemisphere to the western hemisphere, we go from being 12 hours ahead, which is what's happening here, to 12 hours behind, which is what's happening here. And so when we do that, we're going to lose a day. Okay, so the time remains the same, but the calendar goes back by 1 day. Okay, so if we go in that direction. So for context, for those of us here in Australia, that would be for us travelling from Australia, which is here, or from Melbourne here, which is at +10, to, somewhere over here to America. Okay, we lose a day when we go from Australia to America. Okay, and that is going, if we think about just travelling the direction that you are actually travelling in an easterly direction, going that way. So we'll lose a day crossing the date line this way, okay? And obviously the other way, if we travel, now this again, this should say, now where's the sentence here? If we travel across the international date line from, now that should be from the western hemisphere to the eastern hemisphere, so going this way, okay? So if we travel in that direction, but that's actually us traveling west, okay? So it's actually us traveling in a westerly direction. If you were, thinking about being on a plane and making that trip, you're going from being GMT -12 to GMT +12, and so you're going to jump ahead a day. So that's when we return from America to Australia. We jump ahead a day, and so sometimes it means you can lose a day in that process. So international date line. So below, if we have a look at this same representation, but on a sort of map, we've got our prime meridian happening here, running through GMT, and we've got our anti-meridian happening roughly over here, which is where we've got this international date line. But as I said, you can see it's not perfectly straight. It does bend around so that we don't, sort of trap, half of a region or half of a country. In this case, we don't trap the tip of Siberia over there, or Russia over there with, Alaska, or is that Greenland there? Oh no, that's Greenland up there. Alaska over here. So yeah, so it bends around slightly, so it doesn't actually go through borders. But this is our international date line. So as I said before, if we were to travel in this direction, this is plus GMT and this is minus GMT. So we're going back a day. when we go this way, we lose a day. Well, no, sorry, we don't lose a day. We actually gain a day. The date goes back. So, for example, if it was currently 10 a.m. on, I'm recording this on the 5th of September, and I travelled across the international date line. Ironically, travelling at the moment is not possible due to COVID. But if I were to travel from here to America at that time, 10 a.m. on the 5th of September, it would automatically become 10 a.m. on the 4th of September. So we don't actually lose a day, we're actually gaining a day, get to do the 4th of September again, if you know what I mean. Whereas when we go this way, from America back to Australia, we go from being negative minus GMT to plus GMT, so we jumping ahead by a day. So if I was doing that at 10 a.m. on the 5th of September, it would automatically become 10 a.m. on the 6th of September. So that's when I actually lose a day, okay? Because when we jump ahead, I've missed being able to experience the 5th of September. It's already the 6th, okay? So that's how our international dateline works. As you can see, it's not just the international dateline that bends around. There are various time zones where it's about geography. You don't want, you know, if the 15-degree line of meridian of longitude were to traipse right through the middle of a city, you wouldn't want half of one city to be on one time zone and half of the other city to be on another time zone. Similarly, for countries where they're not very big countries, they tend to kind of keep them on the one time zone. You'll see Australia travels across 3 different time zones because we're so big. Interestingly, if you look at China, which is here, China doesn't split its time zones, so the whole thing is on the same time zone. The whole of China is on I think it's on that middle time zone there. So the whole of China sits on that one time zone, even though technically it should probably traverse how many? You know, technically probably 3, 4, even 5 time zones based on its geography. So that would mean that, you know, the times over here in terms of daylight hours, they'd be very different to daylight hours in this kind of country here. In this side of the country here. So, you know, where over here perhaps you might be used to, I don't know, I'm just making something up, but the sun rising at, you know, 6 a.m. in the summertime, over here it might rise at a very different time, much later or earlier, because you're actually not really in the right time zone. Okay, so just getting that sense of what's going on with our time zones, both, you know, geometrically with the 15-degree differences in longitude causing the 1 hour time difference, and the practicalities of that in terms of what it looks like on a map. Now, for the purposes of all calculations involving time zones in further maths, we're just purely going to be going on the longitude, okay? So the, what am I looking for? The sort of GPS, not GPS, but the measure of longitude for the time zone, and we are certainly not going to be worrying about any local adjustments such as daylight savings and other things like that. Okay, let's work our way through 3 examples here. So example 1, find the time difference between Sydney, which is at 34 degrees south, 151 degrees east, and Cape Town, which is at 34 degrees south and 19 degrees east. So the latitude is irrelevant. We're not interested in that. They are at the same latitude, but that actually wouldn't matter either. We are just purely interested in the longitude. Okay, so we want to know what is the difference in longitude. That's the first thing, because then it's going to be about how many lots of 15 degrees is that. So the difference in longitude, 151 take away 19, 151 take away 19 is 132 degrees. Okay, and then we're going to work out the number of hours, number of lots of 15. Okay, so the difference is 132 degrees divided by 15 degrees. So 132 divided by 15, Control Enter, it's 8.8. So that's approximately 9. Okay, so this would mean that there's 9 hours difference. Okay, and so that's actually the answer to our question. In terms of then answering a question about if it was such and such time here and such time here, you do need to be clear about which one's behind and which one's ahead. Okay, so Sydney is more east. Both of them are east of the prime meridian. Okay, so they're both ahead of GMT, but Sydney is more ahead of GMT. So that means that Sydney is ahead of Cape Town. So the time in Sydney would be 9 hours ahead of the time in Cape Town. So let's say, for example, if we knew that it was 10 a.m. in Sydney, that's 9 hours ahead of Cape Town, so it's actually only 1 a.m. in Cape Town. Okay, so being clear about which direction to work that difference is important. But this question just asks us for the time difference, and the time difference is 9 hours. Example 2, if it's 8 a.m. in New York, which is at this location, what is the time in Berlin, which is at this location? So again, the north-south, the latitude measure is irrelevant. Okay, it's purely to do with the longitude, so we're looking at comparing longitudes. Now the thing is that we need to be careful of here is one is west of the prime meridian and the other is east of the prime meridian, so we're not subtracting those longitudes to work out the difference. Okay, so we want to know the difference in longitude, but in this case we're going to need to add, longitude. We're going to need to add the 13 degrees east onto the 74 degrees west to work out what is the actual angle between those two cities. Okay, so 74 plus 13 is going to be 87 degrees between them. Okay, and so therefore we want to work out how many lots of 15 degrees is in 87. So dividing by 15, Control Enter, it's 5.8 degrees. And so that's approximately 6 degrees, which means we have 6 hours difference between Berlin and New York. And now we want to work out a particular time, so it's 8 a.m. in New York. Now New York is further west than Berlin, so Berlin is the one that's ahead. Berlin is ahead of GMT and New York is behind GMT, and so therefore Berlin is ahead of New York. And so if it's 10 a.m. in New York, okay, so, sorry, not 10, 8 a.m. in New York, then it's going to be 8 a.m. plus 6 hours. So 8 plus 6 is 14, which is actually 2 p.m. Okay, or if you're not comfortable with the 24-hour time, you're going to need 4 hours to get to midday, and then you've got another 2 hours. So it's going to be 2 p.m. in Berlin when it is 8 a.m. in New York. Alright, now if you want to, sort of check using Google, what is the current time in New York and what is the current time in Berlin, again, be wary of the fact that that could factor in, there might be some daylight savings time happening there, so it might be sort of an hour one way or the other out. So as I said, in Further Maths, we ignore all daylight savings things, we're just focused on the time differences based on the 15 degrees. Okay, final question here. The time difference between Melbourne, which has a longitude of 145 degrees east, and New Delhi, which has a longitude of 77 degrees east, the time difference is 5 hours and 25 minutes. Okay, now that's a really precise time difference, and that's based on a really accurate calculation of the angles. Technically speaking, it wouldn't actually be 5 hours and 25 minutes, because even though based on the longitude maybe that's what it should be, actually it would either be 5 or 6 depending on which time zone each of those cities are in, but we'll go with the information in this question for now. The time difference is 5 hours and 25 minutes. Now we need to understand from our understanding of what happens here which one is ahead. So Melbourne is further east than New Delhi, and so it is further ahead. Okay, so New Delhi's time plus 5 hours and 25 minutes will take us to Melbourne's time. It takes 12 hours and 25 minutes to fly to New Delhi on a direct flight. At what time would a tourist land in New Delhi if their flight left Melbourne at 5:45 p.m? Actually, do you know what? I'm just thinking about this 5 hours and 25 minutes. I don't even think that's correct on the basis of those longitudes. Let's actually calculate it. Let's work out the time difference, okay? I'm going to not give you the time difference. We've been given the longitudes. We can work out the time difference correctly based on that. And we're not going to use a weird 25 minutes because actually it shouldn't be 25 minutes. There wouldn't be a time difference of 5 hours and 25 minutes. You do sometimes get half-hour time differences. If we go back to the map, you'll see here, for example, Adelaide is on a half-hour time difference from Melbourne or from the eastern states. So you'll see those are specified in certain places. Oh, look, there's actually a 15-minute difference happening there. So there are a couple of places where that happens, but we'll go. But they're never going to be 25-minute differences. So let's actually work it out properly. So let's work out the difference in longitude. Okay. Difference in longitude is 145 minus 77. 145 minus 77. So that is 68 degrees. Okay. And then 68 divided by 15. Oops, Control Enter. is approximately 4.53. So this was where we perhaps wouldn't use this as an example because it is really between 4 hours and 5 hours time difference. Let's round this, we would round 4.5 up to 5 hours, okay? So we'll go with 5 hours time difference, and then that's kind of close to what we had in that example there. So 5 hours time difference, we'll use that, okay? Alright, it takes 12 hours and 25 minutes to fly to New Delhi on a direct flight from Melbourne. That should say really. At what time would a tourist land in New Delhi if their flight left Melbourne at 5:45 p.m.? Okay, now there's a lot of numbers going on here, and it's really easy to lose track of what's happening here. So what I would suggest you kind of do is organise your information. I'm a big fan of this in lots of different areas of maths, but let's think about what we've got here. We're starting in Melbourne, aren't we? So let's put Melbourne first. So we've got what time is it in Melbourne, and we've got what time is it in New Delhi, okay? And then we've got takeoff and landing, okay? Now, the key thing to understand is that the time difference is 5 hours, so that means we're going to add 5 hours from the bottom row to the top row, okay? The flight time, so the time between takeoff and landing, is 12 hours and 25 minutes. So you're going to be adding 12 hours and 25 minutes this direction. Okay? So let's be clear about where we're starting, where we're trying to get to. At what time would a tourist land in New Delhi if their flight left Melbourne at 5:45 p.m.? Okay, so we've been given the takeoff time, 5:45 p.m., and this is the time that we're trying to work out. Okay, so that's where you've got to be clear about what's happening. So either you're working out what is their landing time, but at Melbourne time first, and then you work out, change that to New Delhi time, or you're working out, okay, what time are they taking off on New Delhi time, and then you add on your 12 hours and 25 minutes to work out when they land. Okay, so it doesn't really matter which way around the table you go. You're either going to go from here to here and then here to here, or you're going to go from here to here and then here to here. Okay. But it's just being clear about what it is that you're actually calculating. I think a little table like this helps you to sort that out. Okay, so if we take off in Melbourne at 5:45 p.m., okay, that's 5 hours ahead of New Delhi, so that's equivalent to 1:45. Sorry, it's not 1:45. 12:45. I take off 5 hours. 12:45 p.m. in New Delhi. Okay, so when we take off in Melbourne, the time in New Delhi, it's 5:45 in Melbourne, but it's actually 12:45 in New Delhi. And so therefore, then we're going to be travelling for 12 hours and 25 minutes, so we want to add 12 hours and 25 minutes onto this 12:45 time. Okay, so obviously, again, a bit of finger counting and all sorts of things. So if you add on the 12 hours, you're going to be at 12:45 a.m., all right, and then we want to add on the extra 25 minutes. So 25 minutes is going to take us to 1:10 a.m. Okay, so that will be the next day. Okay, so let's say that if this time was on the 5th of September, then this time would be on the 6th of September. Okay, as I said, you could also have worked the other way instead. So you could have gone this way and worked out, okay, well, the landing time on 12 hours and 25 minutes after 5:45 p.m., okay, if I add on the 25 minutes, that takes me to 6:10 p.m., and then the 12 hours, that's 6:10 a.m., okay. So I'll be landing in New Delhi when it is 6:10 a.m. in Melbourne, and then I can do the conversion from Melbourne time to New Delhi time by taking off the 5 hours. Okay, so whichever way you go about it. But as I said, a little table here to organise what you actually have and what you're actually trying to find is a really helpful thing. So in terms of our answer to our question, so therefore we will land in New Delhi at 1:10 a.m. the following day. Okay, it doesn't actually ask for the following day bit, but just so 1:10 a.m. would be sufficient, but just to be clear what's happening. Okay, so the work there is exercise 19C.